In this video we're going to prove the discrete Schwarz inequality for complex valued sequences. We start with a polynomial p lambda equals the summation from 0 to n lambda modulus of zj minus modulus of wj raised to the power of 2, and this can be bigger than or equal to 0. So let's expand this. It's going to be lambda squared modulus of zj squared minus 2 times lambda modulus zj modulus wj plus modulus wj squared. We can party the summation here, sum from 0 to n lambda squared modulus of zj squared minus 2 times lambda sum from 0 to n modulus zj times modulus wj plus summation from 0 to n modulus of wj squared. We want this to be bigger than or equal to 0, so there is case where the discriminant of this polynomial is the discriminant should be less than or equal to 0. The discriminant here is b squared, so it's going to be 2 times this quantity here, this term, raised to the power of 2 minus 4 times the summation from 0 to n times the summation from 0 to n of wj squared. Okay, let me write it underneath. The discriminant is going to be 4 times the summation from 0 to n zj in modulus times wj modulus to the power of 2 minus 4 times the summation from 0 to n modulus of zj squared summation from 0 to n modulus of wj squared, and this should be less than or equal to 0. So that's going to give me summation from 0 to n modulus of zj times modulus of wj raised to the power of 2, and this is bounded by the summation from j0 to n modulus of zj squared summation from 0 to n modulus of wj squared. So from here we get that the summation from 0 to n of zj modulus times wj modulus is bounded by summation from 0 to n zj modulus squared to the power of a half summation from j0 to n wj squared to the power of a half. And we consider the zj and wj to be complex valued sequences. J runs is the label that goes from 1 to n, from 0 to n, and wj, j goes from 0 to n. So let me correct this. These are complex valued sequences, except when we are at the origin in the complex plane, because if zj equals 0 plus 0i and wj equals 0 plus 0i, then the equality holds. So we have 0 and the left hand side is 0, the right hand side is 0, so the equality holds in this case. And this concludes my proof here.